mic is live, Chris. I can hear you on my screen.
Aloha and good morning. Welcome to today's session of the Women in Space Exploration Talks. My name is Mimi Fuchs. I've had the good fortune of being able to host this really wonderful speaker series that's been really generously put together by Pisces and supported by Microsoft and the Hawaii Science and Technology Museum. I love space, I love outer space, and today I'm so excited to be joined by Emily Calandrelli, MIT engineer turned TV show host. She's done it all, folks. Maybe you guys have seen her in Emily's Wonder Lab. Maybe you've seen her on Exploration Station. Maybe you've even read her children's science chapter books, the Ada Lace Adventure series. She really has done so much as an engineer and as a science communicator. So we're very fortunate to have her join us today. Now, the way we're going to be doing it this morning is a little bit different. Emily's going to speak to us for the next 15 minutes or so, and then you have an opportunity to ask her all of your burning questions. Our question and answer session will be about 15 minutes. So now's the time to start getting those juices flowing, thinking about what kind of questions you want to ask Emily. Once you're ready, feel free to shoot them off in the meeting chat window. Now, this series is supposed to get all of us excited about space, but we're especially excited that we can provide a little bit of career exploration for so many of you younger participants. So to make sure we answer your questions, when you reach out to us via the chat window, make sure you put the hashtag WiSE so we know that you're a participant who's looking to learn more about career options in the space exploration industries. I also would be remiss not to mention that this is a very exciting week for science and for women in science in general. We have 3 women who were awarded the Nobel Prize, 2 in chemistry, I believe for their work on the CRISPR gene editing tool, Emmanuelle Charpentier and Jennifer Doudna. And then a personal hero of mine, Andrea Ghez, was awarded the Nobel Prize for her work in helping uncover some of the mysteries of black holes. So a very big congratulations to these women and for continuing to serve for an inspiration for us all. And now, without further ado, I hand it over to our host for today, Emily Calandrelli.
Okay, Mimi, it looks like Emily is still trying to get joined.
Awesome, not a problem. We have a little bit of time as we wait for Emily to get started. So if any of you guys have any questions you'd like to hear, maybe some things that we could focus on during our question and answer session, now is a great time to do it. Feel free to send along anything you'd like to learn about to the meeting chat window. And thank you so much for your continued patience for us as we get everything set up over here. While we wait, I also would be remiss if I didn't tell you that this isn't the only really awesome presentation we have today, right? So all throughout this week, we have been working with a variety of really incredible women who have made incredible contributions to the space exploration industry. And so today we're really excited to have 2 folks with us. We have Emily Calandrelli joining us in just a few moments. And then later in the afternoon or in the morning, depending on where you're tuning in from, at 10 a.m. Hawaii time, we'll be meeting with Sarah Laneberg, who's going to tell us a little bit about this really exciting helicopter that is traveling with the Mars 2020 Perseverance rover and will act as a buddy to help us study the Martian surface in a way we've never been able to before. All right, without further ado, Emily Calandrelli.
Hi, everyone. Can you see me and hear me?
We can hear you, and now we can see you too.
Okay, wonderful. Great. Sorry, that was a little confusing. But yes, hi, I'm happy to be with you guys here today. As she mentioned, my name is Emily Calandrelli. On the internet, I am known as the Space Gal. That's because I studied a lot of aerospace engineering before I started my career today. So today, I am a science TV show host. I am a science communicator on various platforms like Twitter and TikTok and Instagram and Facebook. But it all started off when I started studying aerospace engineering. So I went to undergrad at West Virginia University, where I studied mechanical and aerospace engineering. And then I went to MIT for graduate school, where I studied aeronautics and astronautics engineering. And then I got a second master's in something called technology and policy. But when I was graduating from MIT and looking for a job, I got a call from a production company that asked me if I wanted to be the host of a new space show called Exploration Outer Space. And that sounded like a fun adventure at the time. And I thought, well, I've never done anything like this before. I've never done anything on TV before. It sounded like quite an adventure. And so I said yes. That was 7 years ago. We are moving into our 6th season of Exploration Outer Space. It's been nominated for, I believe, 3 Emmys now. And it's been an adventure of a lifetime. As the host, I get to travel all around the country to private space companies and universities and NASA centers and just various space-related organizations to talk to the coolest people that are working on space projects today. And we talk about everything from rockets and spaceships and rovers on Mars and searching for aliens and everything in between. I've gone scuba diving to different habitats and where astronauts train in for long time. I've gone to the middle of a desert in Utah to see the Mars Desert Research Station there, where astronauts train for various periods of time. I have jumped out of a plane to show how parachutes help land payloads to planets. I went to Russia to train like a cosmonaut at the Yuri Gagarin Cosmonaut Training Center in Star City, where I rode in a human centrifuge, which if you've never seen a human centrifuge, it looks a little bit like this, where the human is sitting in the fist and it moves like that, kind of like an amusement park ride. And they do that so that the people in the fist can feel various gravitational forces or G-forces, and the same G-forces that an astronaut or a cosmonaut would feel on a rocket launch into space. So it goes pretty high, but I experience up to 4 G-forces. And that's the nominal or the normal maximum that an astronaut or a cosmonaut would experience on a rocket launch into space. So that was really cool. I've gone in aerobatic planes. I went in this one aerobatic plane that was designed by Burt Rutan, and it was flown by Dick Rutan, his brother, who was one of the pilots who flew the first, I believe, it was nonstop, non-refueled flight around the world. And in the plane, it had a sign that said something like, warning to the passengers, this plane has not been approved by the FAA, because it was an experimental plane that his brother had designed. And then Dick Rutan wrote under it, that's what makes it so fun. And so that was pretty interesting. I've just had a lot of adventures to that show that I'm really proud of. And after Exploration Outer Space, I started writing children's books. So I'm the author of the Ada Lace Adventures, which is a children's chapter book series with a little girl named Ada who loves science and technology and goes on adventures to solve mysteries. It's a mystery series with technology and gadgets that she builds herself. And so that series was really my project of creating something that I wish that I had when I was a kid. When I was a kid, there were plenty of books that had science and adventure, but they often had boys who were the main characters. And so I wanted to create something in the world where you had that same sense of adventure and that same sense of science and technology themes, but had a girl as the main character. The 3rd book in that series, I sent to space, to the International Space Station through a program called the Storytime from Space program. That was one of my all-time life highlights, being able to send something that I wrote on a SpaceX rocket to the International Space Station, and then see my book in the hands of an astronaut. And it was astronaut Anne McLean, and she read my book for a read aloud. So the Storytime from Space program is a read aloud program where they hand select some of the best books for kids, and they send it to space, and then the astronauts will read it on board the space station, and they'll video the whole thing. And so you get this like cool video of an astronaut floating in space reading a kid's book, and then it creates this wonderful video that you can show to children all over the world of a read aloud from an astronaut in space. And so you can see on YouTube, there's an astronaut reading my book, Ada Lace, Take Me to Your Leader, while she's floating, and you can see an image of the Earth in the background. And it's just like, it's the coolest thing. So that was a life highlight. And then more recently, I got my dream job. I sold a show at Netflix called Emily's Wonder Lab, where I'm the host and an executive producer of the show. And Emily's Wonder Lab is a science show geared toward kids ages 4 and up, where I do science experiments with kids. And so each episode, there's 10 episodes in the first season. Each episode has me doing one larger than life science experiment. So think creating an entire pool filled with slime, where kids get to learn about polymers and how slime is created, and then the kids get to swim in the slime. And then at the end of each episode, we do an at-home experiment where people who watch the show can bring the science of Emily's Wonder Lab into their own homes and create a mess in their own living rooms, a mess in their own kitchens in the name of science. And so that show has been just such a dream come true, being dubbed over in 38 different languages. These are all the things you don't really think about when you're creating a TV show, because the show is geared toward kids ages 4 and up. Well, kids ages 4, 5, these kids don't read yet, right? So if you're bringing a show like this to different countries that don't speak English, you can't just subtitle it. That wouldn't work because they can't read them. So instead, you have to hire voice actors who speak different languages and dub over every child in the show and the host of the show. And so me and my 10 kids on the show, my little scientists, are all dubbed over in 38 different languages. And it's so fun. In the United States, you can listen to 5 ones in French and German and Spanish and Mandarin. And it's the most unique thing about that show is that I filmed it 9 months pregnant. I sold the show when I was about 5 months pregnant, and Netflix asked, do you want to film this before or after the baby comes? And I didn't know what it was like. Maybe I hear that it's pretty hard, or I heard that it was pretty hard. And so I decided to film before the baby came. And it was really fun. I was lucky enough to have a pretty easy pregnancy, and I had all of this energy because, of course, I'm doing my dream job. I'm filming my own Netflix show. And so I had a lot of adrenaline and excitement. And now there is a woman hosting a science show on Netflix. That alone is really unique. Most science networks, like the vast majority, are men. And so that is unique in itself. And then having a pregnant woman host a science show on the largest streaming platform in the world, that is really, really unique. And I think it speaks volumes as to who is welcome in science, because oftentimes the media science networks are not really sharing this message that women are welcome in STEM, because they don't often select female hosts to host their science shows. Or in movies, when you have scientists in movies, you don't often have women. In books, they aren't often women. And so we're not really sending a great message to kids as to who is welcome in these fields. And I think this show helps move the needle in the right direction in terms of representation, which I'm very, very proud of. But I also wanted to share with you how I got excited about space exploration in the first place and how I became interested in. When I was younger, I didn't consider myself one of the smart kids necessarily. I grew up in a college town, and the quote unquote smart kids in my town were the kids who had parents who were professors at our local university. These were kids who came from families of scientists or engineers. Their family all had PhDs, like they had tutors for everything. They applied to all the best schools and they got into them. And I was not one of those kids. I am the first person in my family to pursue a degree in STEM. I had no idea what I was doing. And the reason that I decided to get into it initially was not necessarily because I thought I wanted to be a scientist or an engineer. I didn't know any scientists or engineers. So that dream wasn't really available to me necessarily. I didn't see myself in that career. I knew that I liked math, and I knew that I wanted a good job. So when I was a high school senior, I Googled all of the majors one could major in college, and I looked at their starting salary. And across the board, I learned that engineers made pretty good money. So I went into, I started university deciding that I was going to, the next 4 years of my life are going to be awful. They're going to suck. It's not going to be good. But at the end, I'm going to get a good job. That was my mindset. That's what I was thinking. But what I discovered was that I'm kind of good at this. You can make yourself one of the smart kids. And B, there are so many adventures that you can do when you are pursuing a degree in STEM that I just wasn't aware of. I had so much fun as a student in STEM. I got to travel to different places to do paid internships, right? Paid internships, because that's kind of unique. I got to live in California for a while. I went to China for a little while to do a paid science internship. All different scholarships through NASA that helped me pay for school. I was part of Engineers Without Borders that allowed me to travel to Mexico and design and build a greenhouse there using some of the engineering skills that we were learning in the classroom to help people in Mexico. And I got to fly on something called the Vomit Comet. Now, the Vomit Comet is truly the reason that I decided to pursue aerospace, because I get into university, I'm sort of reluctantly there. I don't really know what I'm doing, and I definitely don't know what type of engineering I want to do. But I remember walking down the hallways of West Virginia University, and I saw a poster on the wall that had a student floating weightless. And that it said on the poster, do your homework. And I remember thinking, what kind of nerdy metaphor is this? What's this all about? And it turns out that it's a class that you could take if you studied aerospace engineering, where you got to design a science experiment with your friends, your classmates, and apply to NASA to fly on something called the Vomit Comet. And I didn't know what it was, but I thought that sounded really fun. And so I decided to study aerospace engineering so that I could do that. So if you haven't heard of the Vomit Comet, let me explain. It is the coolest thing that you will ever learn about. The Vomit Comet is a plane that flies like an 8,000-foot roller coaster in the sky. And it does that to create this feeling of weightlessness. So if you've ever ridden on a roller coaster, you know that when you go over the hump, oftentimes your butt will lift off your seat, you'll get that butterfly feeling in your stomach, and you'll get a little bit of airtime for a brief second. And it's a really fun feeling. I love that feeling when I'm on a roller coaster. Well, this plane does that, but just in a larger way, until you feel that weightless feeling where your butt lifts off your seat for about 25 seconds. And so, of course, the plane has to dive back up because it can't keep going down towards the ground for obvious reasons. And when it goes back up, it's kind of like being in a roller coaster or being in a car going up a hill, where you feel like you're being pushed back into your seat and you feel about twice your weight. So you feel weightless and then really heavy, and weightless and then really heavy, and weightless and heavy, and weightless and heavy, and weightless and heavy for an hour and a half, which is why they call it the Vomit Comet. Because if you rode a roller coaster that intense for that long, you might get sick. And so speaking of that, when you get on the Vomit Comet, you wear a flight suit. And in that flight suit, you have a pocket right here. And in that pocket, you bring the most important tool that you will bring on that plane. And you might be able to take a wild guess as to what that tool is. It's a barf bag. It's a barf bag, because if you throw up when you're weightless, where does that throw up go? It goes everywhere. And like, keep in mind, this plane has electronics everywhere, because remember, we got on the plane because we all designed an experiment, and we're not the only ones with an experiment on that plane. So there's electronics on the ground and on the walls and just everywhere, and throw up and electronics, they don't mix. And so when you get sick on the plane, which you often do, you get your barf bag and you barf in your barf bag and you tie it off, and then you pass it off to someone who worked there, which is maybe not the best job in the world, but it's a very important one. And so when I first got on this plane, they tell you, take it easy, because your body's never experienced anything like this before. It may get a little confused. Now, this happens to real astronauts when they go into space. They experience something they refer to as air sickness. This is very similar to seasickness. Now, when you experience air sickness, your body is kind of confused about this weightless feeling. It's never felt this way before. And sometimes when your body is confused, it throws up because it thinks that you may have ingested something that is messing up your brain, that is kind of making you see something that's not really happening, right? And so they tell you to take it slow. But of course, when I get on this plane, I'm like, woohoo, I've never experienced anything like this before. I'm doing backflips. I'm flying from one end of the plane to the other. I am just going buck wild. I'm having the best time of my life. You can't wipe the smile off my face. It is pure euphoria. So of course, I am one of the lucky ones who experience air sickness, and I have to grab my handy dandy barf bag and put it to use. And so the first time I flew on the Vomit Comet, I had to sit down after my first few parabolas and collect myself. And then I was able to get back to the mission at hand. I have been lucky enough to fly on the Vomit Comet 2 more times because of my show. And I've finally got my air legs, like my sea legs. I've got my air legs, and I haven't gotten sick since. But it does take a little while to get used to, but I'm telling you, it is the coolest feeling I've ever felt in my whole life. But of course, the Vomit Comet isn't just a joyride. It can be. You can actually buy a ticket on the Vomit Comet for like $6,000, I think. It's not cheap. I would recommend the best way to get on the Vomit Comet is to study science and engineering, because then you can do what I did when I was an undergrad, design an experiment with your friends, apply to NASA, and then fly on it for free, which is key. Very, very fun. But you use this as a laboratory. This is a laboratory in the sky. And one of the reasons it's so important and so useful is because if you're eventually wanting to get something into space, say a satellite or an experiment or just anything into space, it'll cost you tens, sometimes hundreds of thousands of dollars, and for the really big stuff, millions and millions of dollars. It's expensive to get something into space, right? So flying on the Vomit Comet, now all of a sudden a few $1,000s doesn't seem like that much money, right? You can test out your satellite or test out parts of your satellite or test out your experiments in this plane much, much cheaper for a fraction of the cost than what it would cost to send it into space. Now, remember, you only get about 25 seconds of weightlessness, maybe 30 times. So you have to be really smart about how you're using that time. But it could be a very, very easy and fast way to tweak your experiment and make sure that your satellite's going to work when you finally send it into space. So when you get on this plane, you see all types of experiments, because if you can imagine, so many things work differently under weightlessness, right? So something like fire works really differently under a weightless environment. Here, when you light a flame, what shape does it make? It makes like a teardrop shape, right? A teardrop shape. It only makes that shape because we have gravity. Because hot air, which is less dense than regular air or cold air, rises. And that convection, that movement of air currents, creates that teardrop shape. If you didn't have gravity, if you were in a weightless environment, what shape does the flame make? It goes out equally in all directions. You get more of a ball in weightlessness. And so you can even Google this. You can Google what a flame looks like in microgravity. You'll see it's like a ball of fire. And this is really important because if we're going to fight a fire in space, we need to know how it grows and we need to know how it spreads. So studying fire in space is something that NASA is doing all the time. It's a very important thing to do. Also, exercising in space. Exercising is something that's crucial to astronauts because being weightless means you have, you're basically making it easier on your bones and your muscles. You don't have to hold all that weight up all the time. And when you're not doing that, then you have muscle atrophy and you have bone density loss. Basically, your muscles and your bones get weaker over time. To combat that, one thing that astronauts do is they work out for 2 hours a day. But how can they work out when there's no gravity forcing them down? Imagine running. With every step that you take, gravity is forcing you back down. If you didn't have gravity with the very first step that you take, your head would bounce off the ceiling. So instead, what they do is they have like bungee cords that they connect to their arms, and they force you down mechanically, kind of like a spring. It's like if you had a rubber band and you stretch your rubber band, after you let it go, it wants to go back to its original form. So you have like a rubber band of sorts over each of your shoulders. And so instead of having gravity force you down, you're using this mechanical spring-like device to force you down. You have to get really innovative when you're weightless. And so one of the times when I was on the Vomit Comet, I saw somebody testing out a treadmill that's supposed to operate in weightless conditions. And that was really cool to see. That was pretty neat. So anyways, the Vomit Comet is this wonderful, wonderful device that is used for both joyrides and for science experiments. And it was the reason that I got into aerospace engineering. And so long story short, my goal, or I kind of reluctantly joined engineering. I thought it was going to be way too hard and not that much fun, but it was going to be worth it in the end. But eventually I became to fall in love with it. I became obsessed with it. I was obsessed with the adventures, with the concept of space exploration and expanding our human reach into the cosmos. And I saw all of the benefits that space-based technology has for people here on Earth. And I just became enamored with the whole thing. And I try to share that passion that I discovered about science and space exploration with other people. Now through my show on Netflix, through my show on Fox, Exploration Outer Space, through my books, and many times through TikTok. I was working on a TikTok video before I joined this. And so if you follow me on TikTok there, I'm working towards 500,000 followers there. So if you're not following me there yet, you should follow me there. I'm at the Space Gal. But I'm trying to share my love of science with as many people as possible. And I'm happy to take as many questions as you all have.
Awesome. Thank you so much, Emily. You are so cool. You have done so many exciting things in your career working in aerospace and working in science communications. And you have done so much to change the representation of what it means to look like a scientist. I guarantee you, all throughout neighborhoods across the world, you're going to see lots of pink overalls and science lab coats.
Oh, that's
really,
so great.
It's so important to have folks who are going to help us do all the nitty-gritty STEM things, and we also need folks who are going to share it with everybody. I have learned so much about space exploration from following the Space Gal, so I highly recommend everyone else follow as well across social media platforms. And Emily, thank you so much for sticking around for a few questions. We have so many people tuned in who are asking questions. We even have Julia Velasquez, who you worked with as our student astronaut. From the Exploration Outer Space astronaut competition you had that was featured in Hawaii a couple years ago.
She is
so
awesome.
We're so excited to have Julia here. We're excited to have everyone who tuned in. Thank you for all of your questions. And if it's okay, Emily, I'm just going to start throwing some your way.
Let's go. Let's do it.
Awesome. All right. So we have a couple from very young participants. These are under the age of 10. So how did you get the ideas for the science experiments in Emily's Wonder Lab?
Oh my goodness, yes. So, so many of those science experiments have been done by teachers and educators for decades. So there's not really many of them that we kind of made up ourselves. Every time we found a really fun science experiment, what we would try to do is we would say, how can we make this bigger, right? Instead of just creating slime, let's make a pool of slime. Instead of just making oobleck, let's make a pool of oobleck. Pools of stuff was a very popular theme on our show. The oobleck episode, I think, was one of my favorite pools of stuff. If you guys haven't seen that one yet, that one's really, really fun. And then we'd ask the question, how can we make this a game? How can we make this more fun for the kids so that it feels like a game? And then how can we make it colorful? So we took a lot of the science experiments that people have been doing for decades over the years. Teachers are so absolutely incredible. They've been the ones that have been finding creative ways to teach science for decades. And so we're very thankful to that work. But yeah, we've tried to make the science experiments that were already out there in the world just bigger, brighter, and more colorful.
I also feel like I have a couple questions from some aspiring participants on the next season. Did you know them beforehand, and how do you get to be on this TV show?
Oh my gosh, I love that I get this question. So many kids have asked if they can visit the physical Wonder Lab, which would be my dream. My goal is to create like a Disney World type physical Emily's Wonder Lab that kids can visit and find constructive ways to explore their curiosity in science. And I think that would be so much fun. So these kids, they're kids in LA. These are kids who have done acting before, and they did have to be genuinely interested in science. I know that the interview process, we asked them a lot about science. And what was my favorite part on the show is that so much of the show it's not acting. Like, we didn't tell the kids what the experiment was before they got to the Wonder Lab. They just entered the Wonder Lab the day of, and all of those reactions were genuine. And that helped with a number of things. I think one, it's just fun to watch kids react to science in an authentic way. I think that's really, really cool. And two, it helped me be more genuine and authentic, because every time I step into the Wonder Lab, I'm actually trying to teach my little scientists about the science that we're doing in the lab that day. So I'm trying to make sure that they understand. I'm watching their facial expressions to see where they get confused and where they get excited, and what questions they have along the way. So oftentimes, as we're doing these science experiments, they have a question that I didn't prepare for, but I'm like, you know what, that's a really good question. Let's think about that. Let's dive into that one. And so I don't do the casting on the show for potential future seasons, so I don't know really how you get to be one of those kids in the show. But yeah, I think they feel it was a very, very fun experience. And I think the kids that were in the show had a really good time.
That's awesome. Clearly we have a lot of fans of your TV shows. Did you enjoy working on Bill Nye Saves the World? And would you say you're good friends with Bill Nye?
Oh, Bill Nye Saves the World. I forgot to even mention that one. That was such a fun adventure. So I was a correspondent on the Netflix series Bill Nye Saves the World, which was a little bit different than what I had done before, because the science topics on there were a bit more geared toward adults, and it was more international. So for that show, I got to travel all the way to India and do different segments on space exploration in India, education of women in India, vaccines in India. And that was just such a wonderful experience for me, because I don't often get to travel internationally for my science shows. And there's, of course, just so much wonderful science and space exploration going on outside of the United States that it's just such a joy to be able to cover those stories. So that was really fun. Working with Bill Nye, dream come true. He is someone that I watched growing up, and he is someone that I admire so much, because he is someone who combines different skill sets to create something entirely new and magical. And so this is something that I love to see in science, when somebody loves science, but also loves other things like writing or music or filmmaking or comedy or art, and they combine those to create something entirely new and captivating and engaging. And I think Bill Nye is the master of this craft, where he combines entertainment and comedy with hardcore science. This guy knows his stuff, right? And so he combines those two together to create something really special. And this is what gives Bill Nye that it factor that you don't often see. And so when I see other people wanting to get into science, I remind them not to leave the other parts of themselves behind, their artistic and creative side behind, because by bringing that with you, you can create that next new thing that nobody has seen before. And I think we need that in science communication. And I would consider Bill Nye a friend for sure. I think that he probably considers lots of people his friend, but I would like to say that I consider him my friend.
Yes. And I think it's so important what you said about how we don't want to leave parts of ourselves behind. It's not like you just take your math skills when you walk into a science or engineering environment, right? We're there as our whole individual ourselves. And so there's no need to hide those other aspects of ourselves, our creativity, our excitement. I tell myself this too, clearly.
Exactly.
Okay, so if it's okay, maybe a couple more questions?
Please, yeah.
Awesome. So one of these you touched on a little bit. So you mentioned doing the cosmonaut training in Russia. And so we have questions about the differences in astronaut training there. And you mentioned a little bit about being able to be a correspondent going to India. So I guess the question is are they different? Are they the same? Is there maybe something you see regardless of where you go when you're doing these features on international aerospace missions?
Yeah, I would say, I mean, the main difference is that different countries have different amounts of money to put into space exploration. So of course, NASA, they're funded much higher than any other space program. And so when we hear about space exploration efforts, that's why you usually hear of NASA. But there are space programs all over the world. And I think the common theme is that they all recognize the benefit to humanity, to their own nation, to their own people when it comes to investing in space-based technologies. Everything from even putting cameras in space to be able to look at their land and see how their land is changing. One of the most beautiful things that's happened recently is that maybe a decade or so ago, we would only be able to see how the planet had changed with images that were like 3 years old, right? We could sort of see how the planet was changing in certain key areas with weather more locally, but like on the whole, we would only receive an entirely new picture of the planet every 3 years. That doesn't give you a really good idea of how our planet is changing, right? Because the planet is changing pretty rapidly. Today, there are so many cameras in space looking at our land and looking at our climate and looking at our weather. We get an entirely new selfie of the Earth every single day. That is such a game changer. And so I think other countries around the world see the benefit in that. Even imagine just natural disasters. When a natural disaster happens, being able to see where the fire is spreading and who needs the most help right now, being able to allocate your resources to the right people at the right time, that can save lives, that can save a lot of money. It's something that's really, really useful. And I know that a lot of other countries recognize the benefit of things like that. So I think that the major theme is that more and more countries are recognizing the benefit of stuff that we do in space and how it benefits life here on Earth. And it's really fun to see the different ways that people are doing it.
That's so cool. And I think there's something that is really inspiring about thinking about all these countries who are trying to further our understanding of space exploration, right? And I think particularly we're seeing in the future more and more collaborations. It's expensive, it's costly, it's really hard. You need to work together in order to achieve our goals. Okay, our final question for today, and this is one that I think you'll be able to touch on really well, which is, what would you tell young girls who are interested by science, but intrigued, maybe a little bit of scared of the math and difficulty? What advice would you give them?
I mean, I would say just continue to keep the big picture in mind, keep your passion at the core of everything that you do, because of course, with any type of job or career that you're going to pursue, there are going to be low moments. There are going to be periods where it feels like work. Even something that you love, there's going to be parts of it that aren't super fun to do. So keeping that passion of why you're doing that, reminding yourself of the big picture of why you're doing what you're doing, that is so key to get you through those low moments. And so trying to find the right type of work that gets you through those low moments, that is often key, because every work has it, every career has it, but you have to have that passion to oftentimes get through it. And then the other thing I would say is that specifically for women in STEM, it's really important that you have strong female relationships with other women who are in STEM as well, because I think having those friendships is really helpful along the way when you experience things that maybe your male peers don't. And they're someone that you can go to and talk to, who you can kind of share those stories with, and they can give you advice on the time when they experience that same thing. And that's been really helpful personally for me. And it can be hard to do because there's not that many of us in some of these STEM fields, not all, but some of these STEM fields. And so pursuing different clubs that are like women in science clubs, like Girls Who Code, Black Girls Who Code. There's that Carly Kloss coding organization. The Brooke Owens Fellowship is a really great fellowship for women and gender minorities in the aerospace industry. And these organizations are out there to help connect you with other women in STEM, and I encourage you to find them and participate in them.
Thank you. And Emily, you do so much to, I think, help make it a little bit easier for women and for everyone to really go in and find a place for them in outer space, in science, but in all the things they want to do. You're a living example of someone who's achieved their dreams and gets to help us out achieve ours as well. So thank you. You know, I feel so lucky that we were able to have you today for our Women in Space Exploration series. And I feel really excited that for all of us tuning in, it's so easy to follow Emily, guys. Go on Netflix, watch Emily's Wonder Lab. I believe you can go on Hulu to watch Exploration Outer Space. Is that right?
Amazon Prime. Amazon Prime
these days, Amazon Prime. And of course, you can pick up the Ada Lace Adventure chapter book series. You can watch Bill Nye Saves the World on Netflix. And then Emily, would you just remind us of your social media handles to follow?
I'm at the Space Gal everywhere, on TikTok, on Twitter, on Instagram.
So easy, at the Space Gal. So thank you so much, Emily, for being with us here today. Again, my name is Mimi. Thank you everyone who tuned in to the Women in Space Exploration Talks. Usually we only have one talk a day, but you do not even have to wait a full 30 minutes until our next talk if you want to come back and learn a little bit more about the helicopter that's accompanying the Mars 2020 Perseverance rover with Sarah Langberg, who'll be with us in 20 minutes. Emily, a big mahalo. Thank you so much. And thank you, of course, to Pisces for putting on the series, and Microsoft and the Hawaii Science and Technology Museum for sponsoring us. Until next time, guys. Mahalo.
Bye.
Oh, friends, I forgot to mention one more thing. If you're still here with us, we would love to hear some feedback. So there's a QR code on the screen. There's a link that you can follow if you just want to use your URL browser. We really want to make these speaker series and these presentations beneficial for you. So if there's anything we can do to make them better, please, please, please give us a little feedback, and we hope to see you at our following talks. Mahalo, guys.